Section 4 is all about inverse functions. And before we get into finding an inverse function, we're going to talk about what an inverse function is and some properties. So let's start with a definition. So an inverse function is a function that reverses another function. So what exactly does it mean to reverse another function? So what that means is if xy is a point on the graph of f of x, then the reverse of that point, which is yx, is on the graph of the inverse, which we use this notation to denote an inverse. So this represents inverse notation. So that's what it means for a function to reverse another function. So something else we know about an inverse function is that their graphs are symmetric to the line y equals x. So if you graph a function and its inverse on the same graph and the line y equals x, they'll be symmetric with respect to that line. So one thing that's useful with inverse functions is the horizontal line test. So what the horizontal line test does is it is used to determine if the inverse of a graph is a function. So just because we have a function doesn't mean that its inverse is necessarily a function. And one way we can determine if it is to graph our function and then use the horizontal line test. And if our function passes the horizontal line test, then its inverse is a function. And if it doesn't pass, then the inverse is not a function. So all equations have an inverse, but whether or not that inverse is a function is something you have to determine. Before we get into any examples, let's talk about how to find an inverse. So there are 3 basic steps to finding an inverse. So step 1, we're going to set our equation equal to y, because normally it will be in function notation. So we want to replace the f of x, g of x, whatever function notation we use. We want to replace that with y. Our second step is to switch x and y. Since we are reversing it, we would switch x and y in order to reverse that function. And then our third step would be to resolve for y. That way we have an equation in a form we recognize. So those are the 3 steps in order to find an inverse. So let's go ahead and do some examples. So our first examples are going to be determined if the inverses of our graphs are inverse functions. So looking at our first function here, we don't need to know the equation in order to determine if its inverse is a function. So we're going to draw some horizontal lines. Because if a graph passes the horizontal line test, then its inverse is a function. And if I look, in order to pass the horizontal line test, a horizontal line has to only touch your graph in one place. And if I look, there are many times when our horizontal lines will intersect our graph more than once. So what that tells me is the inverse is not a function. So the inverse of whatever this function is will not be a function. Our second example here, which is a linear equation, if I draw horizontal lines, it only touches my graph in one place. And if I were to draw an infinite number, they would only touch in one place. So that tells me whatever the inverse of this linear function is, it is a function. So is a function. So similarly to that, if you draw vertical lines through a graph to test if you have a function, you can draw horizontal lines through a graph to determine if an inverse is a function, without actually finding the inverse. So our next example says, if the point 2, -3 is on the graph of f of x, what point has to be on the graph of f inverse? Well, since the definition of an inverse is to reverse another, if I have a point, the reverse of that point has to be on my inverse function. So that tells me -3, 2 has to be on my inverse. I just switched the point, and that's it. So let's go ahead and find equations of inverses. We have three examples here that we're going to be finding the inverses of. So let's start with f of x equals 2x plus 9. So step 1 is to set our equation equal to y. So we're going to have y equals 2x plus 9. Next, we're going to switch x and y. And when we switch x and y, we don't actually move anything that we're multiplying to x with x when we switch it. So instead of saying 2x equals y plus 9, when we switch x and y, it becomes x equals 2y plus 9. So nothing moves with the x when we switch it. Lastly, we're going to resolve for y. So we want to get y by itself. So we have this plus 9. So our first step is going to be to subtract 9. So we now have x minus 9 equals 2y, and then we're going to divide by 2. So that gives me that y equals x minus 9 all over 2. And you don't actually have to simplify this further and break it up into separate terms. You can leave it as a fraction. And then to actually write my answer to indicate that I found the inverse, we're going to go ahead and use our notation. So the f inverse of x is going to be x minus 9 over 2. And this would be my final answer. Our second example is f of x equals 3 over x plus 2. So step 1, set the equation equal to y. So y equals 3 over x plus 2. Step 2 says to switch x and y. So we're going to get x equals 3 over y plus 2. Now we want to start resolving for y. Well, y is currently in the denominator of our fraction. We don't want it to stay there. So we're going to go ahead and multiply both sides by y plus 2 to get it out of the denominator. So we're going to have x times y plus 2 equals 3. So now we need to work on solving for y. I'm going to go ahead and distribute the x inside. So we get xy plus 2x equals 3. Now we can work on getting y by itself. So my first step is going to be to subtract 2x from both sides. So we get xy equals negative 2x plus 3. And then I'm going to divide both sides by x. So that's going to give me y equals negative 2x plus 3 all over x. And again, you don't have to simplify any further than this. You can leave it as a rational function. So using the notation, my inverse function is going to be negative 2x plus 3 all over x. Last example. So we have our function f of x equals x squared plus 5. Start with our first step. Y equals x squared minus 5. We're going to switch x and y, so we get x equals y squared minus 5. And now we're going to work on resolving for y. So our first step is going to be to add 5 to both sides. So we get x plus 5 equals y squared. Now we need to get rid of the square. Well, you need to do what undoes a square. And the way to undo a square is to take the square root. So we're going to take the square root of both sides. So we're going to end up with y equals the square root of x plus 5. And that would be our final answer. So using inverse notation, we have f inverse of x is the square root of x plus 5.